questions did we want to see you go over on the chart writing? The ones I'm seeing the most are 1, 2, and 4, so we'll do those.
Oh yeah, great. No, I meant 2.
Okay, we're doing 2 anyway, so. Yeah. 1 can be done in Desmos, so can 2, and then number 4 can also be done in Desmos. Grab that stuff. Alright, for number 1, I'm going to go ahead and put in the ordered pairs. Focus. Okay, and then I have to count the slope. So I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, over 1, 2, 3, 4, 5, 6, 7, 8, 15. So down 10 to the right 15. So that slope would be which would reduce to negative 2. So if you did it by hand, that's fine. If you count it by Desmos, make sure you're saying that you did it in Desmos. Questions on that one? For number 2, we have to find the line of best fit first. So this is that. I'm going to put in the table, put in all those points. So then I can see my points to make my line of best fit. Type in y1, the squiggly line, the tilde, mx1 plus b. And this would be my equation. If you're writing that you did this in Desmos, you don't have to write this. But if you don't write that, you would need to write your equation. And then we are looking for the closest length of time it should take Marsha's 6-year-old niece. So the age of her niece is 6. The ages were in x, so I'm going to put in x equals 6 and find where those two lines cross. 199.519, the closest to that would be 200, so B would be our answer. So if you don't use Desmos, you would need to write the line best fit and x equals 6. If you use Desmos, you could just write B. Questions on that one? Okay, and then number 4. if I put in the ordered pair and put in the equation that was given, I could count the slope of this line, which would be -1/5. And our new equation has to have a perpendicular slope, so I'm going to type in y equals mx plus b. Add in all my sliders. Change my m value to be, it was -1/5, so I want it to be a positive 5/1, or just 5. And then I'm going to move b until it goes through that point. So then my equation would be y equals 5x minus 7. You could have also done that on the graph if you either found the slope on Desmos or solved it and found that slope. Any questions on that one? There were two things that I needed to mention that I forgot to on Monday. One, if I didn't check your SOL practice, I'm no longer taking those. It will just be a 0. It won't get replaced. Those need to be turned in, checked on the day that I say to get them checked. So the next section, make sure those are checked on Monday because I won't be checking them throughout the week. And then second, the Delta Maths for Unit 9 are like quizzes. They are formative, so they're like quizzes, and I'm treating them as if you were taking the quiz and didn't attempt it, I wouldn't replace the test with it. So if you don't attempt those, I'm not replacing those. So attempt them, try them. Email me so I can update your grades also. Today we are doing some more graphing, but now we're talking about a different type of function. This is still 10.1 because all of it is graphing exponential and quadratics and finding their characteristics. So for this, we're going to let a and b be some real number constants, and this is going to be an exponential function. As a function written in the form y equals a times b raised to the x power, where a does not equal 0, b is greater than 0, so it's positive, and b can't equal 1. Right, here are some different examples of what this may look like. There are also more that could go into that. You could be adding things, multiplying different numbers, making it negative. We'll get into that. So in this first example, we're going to graph it by hand. I've given you some of the stuff in the table. That won't always be the case. But for the beginning, I'm going to give that to you. And then we'll go back and talk about this stuff. So let's say that we just start with these 5 points. You could change that, and we'll talk about that later. Why would we want to change that? And then if we're putting this in where x goes, sorry for this one, we have to think about if I put -2 in here, this would look like 3 to the -2. Same thing with this and all of these. So we're thinking back to our exponent rules. 3 to the -2 would be what? negative 9. It's not going to be negative at all. Say that again. It will be positive, but not 9. It's not going to be 1. So our negative exponent rules, we take the base, we flip it, we make the exponent positive. So that would make this 1 over 3 squared, which would be 1 over 9. So then what would 3 to the negative first be? One-third. Anything to the 0 power is 1. 3 to the first power, 3, and 3 squared, 9. So we have to remember our exponent rules in order to be good at this. Then we're going to plot these points, these x values with these y values. These decimal fractions that we kind of hard guesstimate is okay if it's not completely accurate. So at negative 2, 1/9 would be like really close, but not on the line. Like, I tried to make that lower, but a small point closer to 0 than 1. 1/3 would be a little higher, but my line is only this, so it's going to seem like it's about the same. That actually looks like half, but it's okay. And then these other ones is where we really get to see it. So 0, 1, 1, 3, and 2, 9. And you see it start to do this curve type thing. On both sides, you want to draw arrows. The one going to the left is just going to kind of, mine went back up, but it should be getting closer and closer to 0, but not actually touching it. In Algebra 2, you'll do exponential functions again. You'll learn about an asymptote. It's a line that it gets really, really close to, but never actually touches. I'll show you what that looks like in Desmos and in the calculator here in a bit. So then we can start to fill out some of this stuff. What is our y-intercept? 0, 1. Write it as an order pair. And then we talked about domain and range for quadratic, but now let's apply that here. If we're looking furthest left to furthest right for domain, what would that be here? Where would it start? It goes to negative infinity, so that's where it starts. Where does it end? It ends when x equals 0. It ends when x equals 2. Or does it go past that? It goes past that to where? The arrows mean it keeps going. So just like our quadratics, our domain for this will also be all real numbers, negative infinity to infinity. I'm going to write that in set builder notation also, so we recognize what it looks like. Now for our range, this is where it gets tricky, because we want to say negative infinity, but it doesn't actually go past 0. So we're going to say starts at 0, but it never actually touches 0, so it's not included. So parentheses 0, but where does it end? Infinity. It doesn't. It keeps going. So that would be y is greater than, sorry, not equal to, just greater than 0. And I'm going to show you that on decimals here in a second. And then if we were to approximate 3.07, 3 to the 0.07, I know that'd be somewhere in between here and here. Looking at where 0.7 would be somewhere right here. So maybe like 2.5. I'm so guessing. In your calculator, actually put in 3 to the 0.07 to make it go. So I got the 2 part right, not the decimals, but that's okay because it was a guess anyway. Whether you look at the graph and guess by the table, and then figure out what it actually is, or just figure out what it actually is, as long as you know how to find it in the calculator and could guess it based on the graph or table, you're good. This is how we find our exponential function. Do we have any questions on any of the characteristics, how we graph it? In the calculator, if I were to put this in my y equals, if you graph it, it does exactly what we just did, but it looks like it's on the 0. If I go into the table, the further I go back, the decimals get really small, so small as in scientific notation, so it's getting really, really small, a bunch of zeros in front of these numbers. But if I were to put that into Desmos, the more I zoom in, I see it's not actually touching that number, touching 0. It's just getting really, really close to it. Even when it looks like it's actually on the line, touching the line, it's not. And you could do that to infinity, and it would never actually touch. You could have under and out on your own. Right? So keep that in mind. Even though it looks like it's touching, it's not actually going to touch. Let's do a couple more examples. So in number 2, I again give you your x values. So we have where the x value would be. What would 7 to the negative squared be? 1 over, not 14, but what is 7 squared? 49. 7 to the negative first. 1 over 7. 7 to the 0. 1. 7 to the first. 7 squared. What you end up seeing as you move along the x's is that each time we're multiplying this by 7. And that's how you see something is exponential. It's multiplying by some number exponentially getting bigger. So let's go ahead and graph these points. The 1 over 49, again, is going to be something really, really small, close to 0. 1 over 7, again, kind of the same thing. But then we have 0, 1, 1, 7, and we're not going to graph 249 because it would be way up there. I try to make my line close to 0. Sometimes that works, sometimes it doesn't. Make it look as accurate as possible to the best of your ability. What's our y-intercept?
Oh,
What did you say? 0, 1. Right out of order there. The domain And then the range, where does that start? We're looking lowest to highest. Is that going to go below this line? No. So where would that start? 0. Would that be included, square bracket, or parentheses? Parentheses. It's not included. So 0 to infinity. Or y such that y is greater than 0. If I had to approximate 7 to the 0.5 from the graph or table, what do we think that would be? 2.2. Did you actually find that? Okay. So before we find that in the calculator, let's look at the graph. Still guess.
2.64.
Okay. But it was exactly 2.6. 2.64. Okay, now we're going to change it a little bit. Now our b value is going to be a fraction. We're going to see what changes with that, what happens with that. Same x values. But now I have 1/3 to the negative 2. So I'd be taking that base, I'd be flipping it, making the exponent positive. What would that become? So let's, one thing at a time. If I take that and flip that, what would that become? 3 over 1, I'll just put 3. And then make it positive. So 3 squared is 9. So then what would 1/3 to the negative 1 be? 3. 1/3 to the 0. 1/3 to the 1. Would it change? No. It would stay the same. And then 1/3 to the second power. 1/9. So then graph those. So at -2, we're at 9. -1, we're at 3. 0, 1, still the same. 1, 1/3. And then 2, 1/9. What happened? How is this one different than the others? It's going the other way. Flip. What would that y-intercept be? 0, 1. So that hasn't changed yet. But also we haven't done anything real to it. It's still just whatever the base is to the x power. So that hasn't changed yet. What about the domain? So it's always still left to right. So it's still negative infinity to positive. Or x such that x is an element of all real numbers. What about the range? Is that where it starts or ends? We're thinking lowest to highest. Where does that start? Not 1.
0.
0. Because again, it's not going to go past that line. We are going to do some where it does, but these don't. And then highest, infinity. So even though it's switched direction, it's still doing the same thing. Or y such that y is greater than 0. Okay, before you put it in your calculator, if we were to look at the graph at negative 1.5, what do we think that would be? What? What did you say? At negative 1.5, so somewhere up here.
72.
72. Anyone else want to take some other guesses? think it might be around 7 something.
Told you.
It might be around 6'9".
5.196.
5.19.
I was close. I was closer than you too. I mean, who else guessed?
Sure.
I'm the closest.
Alright, we're gonna do one more today and then we're gonna do some more tomorrow. Go on to the next page. We'll do one more of these types. So for number 4, again we have a fraction base. 1/2 to the negative second would be what? 4. 1/2 to the negative 1. 1/2 to the 0. 1/2 to the 1. 1/2. 1/2 to the second. What's that pattern? What's happening? You're dividing by 2 each time. So then let's graph those. -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4. I tried to make that look a little smaller. I could really go backwards. If I did -3, what would that be? X to the -3. What would that give me?
8.
Just to fill up more of the graph, you don't need that point. Y-intercept there. 1. Keep in mind it won't always be that. We just haven't done anything to change it yet. Domain. Negative infinity to infinity. 4x such that x is all numbers. Range. 0 to positive infinity. Always lowest to highest. Alright, now this one says approximate to the nearest 10th. So just one decimal place. Before you put it in your calculator, anyone want to guess? What did you say? 5.5. So at -2.5, 5.5. So it's somewhere right here.
I think 6.8.
Anyone else want to guess?
Wait, what about 5.3?
You want 2 guesses?
Yeah.
Okay.
5.6.
Okay.
5.4.
Okay.
35. Boy,
I don't think it's going to be that high.
I feel like it.
Because I know that 3 is at 8 and -2 is at 4. So it's definitely going to be somewhere between that. What is it actually?
5.65.
5.65, so they'll round 5.7. So close, not quite. This is just a fun little game. Alright, so tomorrow we're going to do some more examples of this, and then Monday we'll move on to the next one. You guys do have delta math on this, on the quadratics. Quadratics is due tomorrow. This is due next week. The dividing polynomials is part of Unit 9, so that's the last formative delta math. Is also due tomorrow. So make sure you guys are working on that.